Hello and welcome to the course of the strength of advanced strength of material. So in this course, so far what we have studied, about strain energy. Okay. Now in this lecture we will see about simple bending. Next we will see the first chapter is over. We will see in the module 2, that is bending and shear stresses. In this bending and shear stresses module, that is module 2, this is our third lecture of the whole course. This is our fourth lecture of the whole course and first lecture of module 1. So the topic for today is theory of simple bending, pure bending and equation of bending. Now let's start with lecture objective. So the lecture objective of this equations are the lecture objective are to understand, first to understand about what is bending stress. First we will understand about bending stress, then we will see about theory of simple bending, what is the theory of simple bending and how it is developed, and what is the main constituent of the theory of simple bending. Next we will see of the condition of pure bending, what is pure bending condition and how to deal with the pure bending condition, that we will understand. Then we will get an insight of the bending equation. This bending equation, the derivation of this equation is not so important for you, but you should know the equation of bending. So this is your first lecture of this topic, that is bending and shear stress. So let's start. So first you need to understand one thing, that when there is some external load means that a load which is applied on the object. So when there is some external load that is applied on a beam, so shear force and bending moment sets up at the all of the section of the beam. So see, when the external load is applied, at that time what happened? When the external load is applied, at that time body tries to deform. Now body tries to deform in two sense, that is, if a load is applied, in a, this is a body. If a load, this body is supported, say like this, these are the support of the body. Now we apply some load here, so this body tends to deform in two ways. First, it will try to deform in shear direction, and it will try to deform like this. Now in both the two cases, what happened? This deformation is caused by what? This deformation is caused by that particular this force. Now this deformation is registered because, see, in the general application, all of the our engineering application, there is force, but there is deformation in every place? No, we cannot see deformation in every place, because the material inside, the material of the object tries to resist that deformation. By trying to resist that deformation, what the material do? The material will provide equal and opposite reaction to the applied force. So if that reaction is R, now we know the what is stress. Stress is the reaction per unit area. So why this reaction will happen? This reaction will happen due to applied load. So due to applied load, understand the chronology. First the applied load is first the load is applied. Now due to this applied load, there is tendency to deformation is generated inside the body. Now this tendency to deformation is due to that applied load. Now the body, the material of the body tries to resist that deformation, and that's why it will generate some stress. When this stress generated, these are known as this stress generated are known as shear force or shear stress and bending moment or bending stress. So these two things are generated. So So from in the shear force and bending moment diagram explanation in last semester, we have all studied that shear force and bending moment will set up in all the section of the body. So now due to shear force and bending moment, so beam undergoes what? Certain deformation. That thing I am saying, certain deformation, and due to this deformation, due to this deformation, the material of the beam offers a resistance or stresses to the deformations, and these stresses can be calculated with certain assumptions. So these stresses which can be calculated with certain assumptions are stresses that induced in the body. Now this shear stress and bending shear force and bending moment, these two are generated. Now stresses, specifically stresses which induced by bending moment, which induced by only the bending moment, is known as bending stress. So this will our first concern, what? That is stresses induced by bending moment, which is known as bending stress. So for example, say a material of rectangular cross section is under bending moment as shown in the figure. See here, this is under bending moment. So as per bending moment, what happens? The material will bend like this. Now for being bent like this, the upper fiber, this upper fiber, see this is bending moment M. Due to this bending moment, the upper fiber will undergo upper fiber. See in the upper fiber, what is happening? The elongation is happening. So elongation is result of tension. So we can say that upper fiber undergoes tension, while the lower fiber, in the lower fiber, see you can see the length of the lower fiber is reduced. That means there is compression. So lower fiber undergoes compression, and this radius, the radius of the curvature is known as R. This is radius of the curvature. Now from this picture we can say that in the case of bending, so in the upper portion, in the case of bending at the upper portion, there is tension is the tension is there. In the upper portion there is tension, and this tension is being, the tension force is being reduced as it comes to the center point, and after some time the force is the nature of the nature is like this, that is tension. So this is the stress. This is what stress? This is our bending stress. This is our bending stress. So this type of the stress can be generated in case of bending or in case of bending. Now we will see in detail that what is bending stress and how it is calculated and all that. So for that, first we need to understand about simple bending or theory of simple bending. So theory of simple bending is a theory which deals with finding stresses at section due to pure moment, is called bending theory or simple bending theory. So see, if a beam is considered which is initially unstressed, means see this is a beam, this is initially unstrained or unstressed, means that means there is no stress, and this is subjected to constant bending moment. Now if it's subjected to constant bending moment M, constant bending moment M along the length, then what will happen? Then the material will bend like this, and this upper fiber will undergo tension, and while the lower fiber will undergo compression. So and this radius is known as radius of curvature. Now if we consider this, we can say in case of simple bending, so as a result what will happen? That upper fiber or top fiber will subjected to tension. That means top fiber, this top fiber I am trying to bend the material. Try to bend the material like this. I am giving bending moment like this. So that means the material will try to bend like this. Now this bending will give tensile force to the upper fiber. That means the upper fiber will try to expand, while the lower fiber will try to contract. Or in the lower fiber, what will happen? In the lower fiber, compression force will be happen, or compressive stress will be generated, or that lower fiber is subjected to compression. Now in between these two fiber, there must be a surface which is, or there must be a point in which the stress is zero. Now locus of all of this point, is known as neutral axis. So what is neutral axis? Neutral axis is the plane, or is the axis of no stress or zero stress axis, is known as neutral axis. See here, in between upper fiber and lower fiber, that means in between tension, in between the fibers in tension, or in between and the fibers in compression, there is a portion where there is no stress. That means that portion is not in compression, neither in compression nor in tension. So at that place, at that position, or that surface, or that axis is known as neutral axis. Now the radius of curvature is measured to this axis only. So radius of curvature is measured to neutral axis only. So this is the neutral axis. This is the neutral axis. Now radius of curvature, the definition of radius of curvature is the distance between the center point of the curve, or center point of the bending, to the neutral axis. So now this is our radius of curvature, or R. Now the symmetrical section, neutral axis is the axis of symmetry. But whatever may the case, neutral axis must pass through the center of area, or centroid. So this is the main thing, that neutral axis must pass through the centroid, or center of area. So it passed through the center of area, or centroid. So this is the main point, that neutral axis must pass through the centroid point, or center of area. This centroid, where will be the centroid, that we have discussed in the last semester, and the value of centroid, that also I have discussed. In the later section, when we needed, we will discuss them again. What is centroid and what will be the value of the centroid, that we will discuss. So now as per we know, in simple bending, what we have seen already. So in simple bending, the transverse load and the centroidal plane coincide. That means if this is the load, line of action of the transverse load, that means if these two is the line of action of the transverse load, and then the centroidal plane, this centroidal plane will coincide this line of action. So that means these are the main points of the theory of simple bending. This theory of simple bending is developed by Galileo, Sir Bernoulli, and Saint Vincent. And sometimes this theory is also called Bernoulli's theory of simple bending. So I guess you have understood about simple bending. In simple bending, what will happen? Due to pure bending force, in simple bending, due to pure bending moment, what will happen? Due to pure bending moment, or due to bending moment, the material will bend. The material will bend in the direction of the bending moment, and that bending will give one surface, that bending will give one surface to tension and opposite surface and the other surface or the other fiber to compression, and in between them there exists one curve, or there exists one axis which is remain unstressed. That means which will experience neither compression nor tension. So that is known as neutral axis. Now from the neutral axis, our desired point of calculation. So what I have said, that bending stress can be calculated. So our desired point, the distance between our axis of calculation, that means the bending stress calculation point, that is A dash B, if we want to calculate here, and the distance, if the distance is y, then we will see the equation later on. So now this is the simple bending, this is the theory of the simple bending, and we have already discussed about this simple bending theory. Now we will move on to the pure bending. What is pure bending? Say suppose a length of a beam is subjected to, when a length of a beam is subjected to a constant bending moment, when a length of a beam is subject to a constant bending moment with no shear force, when there will be no shear force, that means there will be no shear stress, there will be only bending stress, that at that time the condition is known as pure bending. So see here in the definition, if a length of a beam is subjected to a constant bending moment with no shear force, then the stress will be set up in that length of the beam due to bending moment only. So there is no shear force. So at that point, at that length, when there is no shear force, at that length the stress will set up in the beam due to bending moment only, and that length of the beam is said to be in pure bending. See in this figure, the stress, there is extra, the support A and B are the support, and W, these W's are the external load. Now in this condition, see, this is shear force, and this is also shear force. Now in between this shear force bending moment diagram, in between them in this place there is no shear force, that means the bending moment is constant here. So now from point A to B, this length is, that means from the definition, this length is known as pure bending. This length is in pure bending. So our calculation of simple bending, or the theory of simple bending, revolves only the theory of simple bending is valid only for the condition of pure bending. So what is condition of pure bending? The condition of pure bending is there should not be any shear force. The stress generated should be only by the bending moment. So this is the pure bending condition. So now we will see the what is pure bending in detail. So see, for example, see this figure. This is a simply supported beam A and B, and it is overhanged by same length in both sides, and a point load W is applied in the each side. So from the previous semester, what we know how to draw SFD and BMD, and from the SFD and BMD we can draw this is the shear force diagram, this is the bending moment diagram. Now from this shear force and bending moment diagram, what we can do, we can understand that, we can see that in between A and B there is, so we can see that in between A and B there is no shear force acting. That means in between A and B there is no shear force acting. That give us the constant in between A and B, there will be constant bending moment. That constant bending moment lead to the condition of pure bending. So this is the pure bending condition. Now we will see the equation of bending. As per the equation of bending is given by M by I is equal to E by R is equal to sigma by E. Now this M is known as bending moment at the section, that is in Newton per mm. This M can be calculated from the bending moment diagram, or it can be given to you in the question. That moment of inertia, this moment of inertia calculation, or the value of the moment of inertia for different section, means for circular section, for square cross section, this should be known to you, and these values are given to you in the last semester. If you have those notes, in that you can find out the value of moment of inertia or the formula for calculating moment of inertia. So that moment of inertia of the cross section of the beam should be about its neutral axis, or as the neutral axis coincide with the centroid, so that should be about the centroidal axis of the body. Now sigma is the bending stress, that is bending stress in the fiber at located distance, that means our desired location, that is at y mm from the neutral axis. So distance y is the distance of the fiber under consideration from the neutral axis, that is y, and E is the Young's modulus, and R is the radius of the curvature. So from this equation, E is the Young's modulus, R is the radius of curvature, sigma is the bending stress, and Y is the our desired location of where we want the bending stress. Now in between them, in between these six parameter, if we know only 3 parameter, then other parameter can be calculated. So bending equation, from the bending equation we will see some simple problem in later section of due to bending equation. Now we can say that the bending equation is given by, that is M by I is equal to E by R is equal to sigma by Y. This is the value of the bending equation. We will see the assumption for the bending equation, and we will see how it is derived a bit, but the derivation is not in your syllabus, but in the next lecture we will see about that, how it is derived and what are the assumptions made. So thank you for today. I hope you enjoy this, and if you have any problem you may ask in the live class. Thank you.